ourselves in. All right, I think we're live and ready to roll.
Good. Okay, great. Are we on?
We are.
Awesome. Hey everyone, thank you so much for showing up today, and thank you for coming to the first episode of Built for Motion. It's a live web series that covers all things transit, materials, and testing. With us today, we have a colleague of mine, Greg Wilson of TWMSR. Greg, could you raise your hand? And we also have Rick Reinboldt of InstaCote, leading manufacturer of Polyurea, as well as myself, Sreyas of Megalab Group. Quick overview, there's going to be two presentations today. The first one covering the various test protocols and industry standards utilized by automotive manufacturers at the skid level. The second will be on innovative and industry-leading applications of polyurea foam in racks, carriers, transports, and the like. Please feel free to bank your questions. We'll have some time at the end to answer them one-on-one, and you can also send them in the chat. Thanks again for coming, and I guess let's get rolling into the first episode of Built for Motion.
Thanks, Shreyas. We're going to go offline ourselves so that you can share your screen. But
Perfect.
Nice to see everybody. Glad that you can join us today, and I will see you all soon.
Awesome, and with that, I'm going to take it away. Please give me a second. I'm just going to turn the presentation on and get my video in the correct position. That's awesome. Awesome. So thanks everyone for coming again. I'll be covering the first presentation, and the topic of this presentation is about enhancing automotive packaging efficiency with ISTA testing. Now, the presentation itself is going to cover a few topics, and I'm going to start at a high level and get a little bit more nitty-gritty and detailed as we near the end. The middle of the presentation will cover the different tests, and at the end of it all, I want to tie it together with some case studies based on real life that show the real application of what is being demonstrated here. So first and foremost, I mean, I'm sure being in this industry, we've all heard the term ISTA testing. More often than not, you know, it's a requirement that's handed to us for some sort of a compliance measure. But what does it really break down, and why is it important? Essentially, it's a standardized battery of tests that essentially reduces transit damage, helps comply with purchaser requirements, and provides a baseline, an estimation of the kinds of damage that skids see in transit, and provides to be a very good realistic simulation. Now, when people talk about ISTA testing, what exactly happens in that subset? Now, it's usually, as I mentioned, a battery of tests. These include shock being any procedure that would instantly impact, such as dropping something, dropping it 6 inches, vibratory simulations, things that are modeled after the random vibrations of a truck's axles in order to induce that stress onto the package. Compression, and of course, hand drop. Doing these tests in a particular order not only matches how distribution works, but it also helps to pinpoint vulnerabilities and weaknesses in packaging, so manufacturers such as yourself can address them. And ultimately, you know, I think it's always best to see a package fail on the table rather than in a customer's warehouse or in any sort of real danger scenario to the worker or to the end user. Now, let's talk a little bit about some statistics. You know, how prevalent is it? According to a study by Packaging Digest, as much as source mentioned here, of course, as much as 11% of unit loads arriving at a distribution center have some level of case damage on them. Now, that same study went on to further specify that this is a net effect of 2% damages at the whole skid level. And that's catastrophic. I mean, if you're talking about 2% loss of inventory on parts, at a normal level, that's small, but when you get into volumes, it can be catastrophic losses, right? Now, let's talk a little bit about what exactly happens. So, I mean, let's say that, you know, ISTA testing is mandated or it's necessary for your organization's validation and protocols. What actually happens in there is first and foremost assessment. Why are you selecting that certain test? What's going down with the package level itself, and what are the stresses you anticipate? From there, creating a package prototype, conducting testing on it at a preliminary level, then further refining the packaging till it's passing is a very safe and I guess risk-averse strategy, a way of tackling this without actually encountering that failure in the field. Now, a little more directly, the part that I want to drill in on is this second aspect first of the test selection criteria. Now, what goes into test selection? Typically, there's 5 major high-level points of what manufacturers look at. And from there, I'm going to drill down a little farther into each of the subpoints. First things first, what are you actually shipping? Is it a box? Is it a skid? Or is it a rack, a machine-handled rack of some kind that might get like front bumper parts or something of that nature? Each of those would have its own kind of test method because they're shipped differently. Now, second to that is, how is it actually being shipped? Is it sent in the ocean? Is it air freighted? Is it ground freighted? Is it sent in a truck that has an air ride, or does it have steel springs? And on top of that, what's the duration of travel? Coming from Oshawa to Windsor is a totally different story than making the trip from Guelph, let's say, all the way down to Mexico. And the length of vibration actually dictates the length of simulation as well. Third major point we generally look at are the customer requirements. For example, let's say that good example is your GM vendor, for example, right? And they have their own set of packaging standards that without conducting those expendable pack tests or the returnable pack tests, you wouldn't be able to qualify a pack or submit it into their control system. So more often than not, it's a customer needing it to make the sale that dictates it. One stressor we commonly see manufacturers get worried about is temperature conditions. Things such as, the buildup of humidity. If you think it's going to be sitting inside an ocean freight container for an extended period of time, or you think it's going to be shipped through a rainforest, you think it's going to go through transitions up and down. All of this can be simulated at the skid level, and it helps dictate the program and standard. And then finally, the warehousing and transport condition of the pack. Now, it's a totally different story between shipping, let's say, a one-off of a front bumper assembly for a race car, and you need to make sure that one piece gets to Germany, let's say, and needs to take ocean freight. So it's never going to be stacked one on top of the other. It's one piece that needs to go. Versus if you're making a box of stamp parts and literally thousands get loaded, container loads of the stamp part go through, that might even be stacked 3 high in warehouse transit. So the loading requirements can be different, and the test gets tailored down that way as well. Now, as I mentioned earlier, it's just a series of tests. Actually, I'm going to jump back one slide real quick because there's a point here I wanted to cover. Essentially, I'm going to cover 2 major tests here. One for ISTA 3E. These are unitized pallet loads. The manufacturer scenario I presented where you make thousands of something, you fill container loads, every box, every container looks the same, and they just get stacked in a warehouse again and again and again. There is an appropriate testing for that called ISTA 3E. In the other scenario where you're shipping a crate and it's a novel, it's one-off, it's getting shipped, essentially you're tendering a less than truckload and it's not unitized. There's a separate test for that, and the divergence between them, I'm going to go into a little more here. 3E is more based around tests that deal with warehousing, things impacting the skids and handling, as well as vertical compression. And we see here that 3E has an optional temperature, humidity, exposure condition as well. So if your pack can start at the beginning of this board, travel all the way down through the sequences, and at the end of it, meet the pass criteria, then it would pass the 3E test. Now, this in comparison, the next test I just want to highlight is the 3B test. Now, very similar, but the key inclusions of this test that the other one doesn't have, in this test you would assess tip over. Generally, no one is tipping over skids of unitized stuff, but in the handling environment of less than truckload, then tipping over is a real concern. Incline impacts and drops are the same. Vibration is also similar. However, 3B also includes a forklift handling track. Things involving pushing the skid with a forklift, taking it down a forklift handling track back there and back. And they're very concerned with the third-party logistical handling of a number of shipments you send out because it's more realistic of the environment that a non-unitized shipment would take through its distribution life cycle. Now, touching a little bit on the temperature precondition segments, the ISTA standard defines what are known conditions and generally industry accepted. So, for example, if you thought that you were shipping into an extremely cold, uncontrolled RH environment, the depths of an Arctic country, let's say, then there is a test criteria. Whether or not these are perfectly applicable for your use case depends a lot on your deployment. However, the one thing to be said about these is that they're industry accepted norms. And generally, if you're looking for something to hang your hat on or serve as a starting point for the discussion, these are a very good jumping off board. Now, this is the part that I'm most excited to show you all today because I'm about to present 3 case studies in automotive packaging. The first case study is done from the perspective of an actual automotive manufacturer. So let's say like a Honda, a Toyota, a GM. Their vendors supply parts to them, and they also supply packs to them. A final qualification of these packs, as well as qualification of interplant transports, fall on the auto manufacturer because for them, whenever they lose inventory in process, they actually lose money because it's damage in transit is damage of inventory. So we had a leading auto manufacturer come to our lab and they came to us with this problem, essentially saying, how do we best determine the standards required in order to assess what's happening on our shop floors? So in working with them, we developed a very bespoke and tailored standard in order to closely mirror the 3E standard, but also have some unique stuff that was tailored to their deployment. What ended up happening is we built a protocol for them, and every rack carrier that goes through their manufacturing and goes on their plant for their new model purchase production is qualified to a variant of the 3E test on rack components. So first case study really is that auto manufacturer utilizing it to make sure they're not losing money of inventory in transit. Now, the second case study is actually the reverse perspective, which is we work with a lot of vendors who manufacture the packaging that the auto manufacturer regulates what standard they need to meet in order to submit to them. So this is a real scenario as well. A customer came to us and said, we have 6 or 7 skids that have to be qualified. It's a real problem because suddenly, our client has come and cracked the whip on us saying that they need to have ISTA tests executed and ASAP because we're losing money or we can't submit. So with all that being said, what was vital for this customer, same day quoting, we got a fast turnaround, and then they sent us 6 palletized samples right away for testing to the most generic version of the 3E standard. And the vibration duration was tailored really just to the travel distance that they were making from the plant to the production site. So individual reports created, uploaded to the vendor portal, and then problem solved there. So stage 1 case study, you're the manufacturer qualifying your vendors. Stage 2, you're the vendor being required to qualify for your manufacturer. It can really go either way. And then the third one, this is one of the more favorite ones I have. A leading tier 1 manufacturer was creating a custom hood assembly component for a model of car, which I believe they're only producing something like 20 or 30 unique models of that car. So you can imagine the amount of engineering that goes into creating this hood assembly, incredibly high. And then even one scratch of damage on this thing is unforgivable, right? So the amount of hoops you have to go through to qualify the pack, again, similar, it's just that the shipping method is different. In this scenario, they were concerned about ocean freight as well as ground freight, and they were concerned about whether or not it's forklift handleable. So we went through a couple of revisions with them of conducting the testing and doing the testing with dummy parts, as well as shock indicators, in order to best ascertain what the damage would be. And again, the standard that we applied here was the ISTA 3B standard on a single-use crate, as shown earlier. And finally, I guess in conclusion, ISTA testing isn't going anywhere soon. The reason for this is, damage isn't going anywhere soon. engineers especially always have the problem of, how do I choose what the validation would be? How do I not only make sure that it's representative of the real world stresses, so I'm covered in knowing that, I did a good job validating it, but it's not too aggressive in that it's going to kill the pack for no reason. And that's why it's always good to have an industry established baseline. I think from every perspective, that's why people use them. And at the end of the day, it serves as almost a bastion of quality that everyone can standardize and work around. Any questions, please feel free to type them in the chat, and we'll have some time at the end to address them. Thank you all for listening, and I'm going to turn the presentation off and then get my colleague Greg on the stage as well.
That's great. Thanks, Sreyas. I really appreciate it. It was really cool to see the difference between manufacturer-led testing versus qualifying as a supplier, sort of independently of having those baselines established.
Definitely, Greg, and yeah, you nailed the key point there. Everyone does it for different reasons, but we all do the same thing, right?
Yeah. At the end of the day, you need to get qualified, regardless of who's instigating it.
Absolutely. Well, I'm gonna jump off the stream, and I'll let you go ahead with your part. Thanks everyone again for listening.
Great. All right, everyone. My name is Greg Wilson. I work with Tony Wilson of TW-MSR. We are an automotive manufacturing rep. Do a lot of work in automotive packaging and other sorts of things. InstaCote. This is Rick Reinboldt. Say hi.
Hi. I was just kind of paying attention. I was not paying attention to what I should be doing. I've been in the rack industry for about 30 years. I used to own my own company and co-owner in a shipping rack company in Toledo. And about 20 years ago, when I had brown hair, I started with InstaCote. And I saw a lot of interest in what InstaCote had as it applied to the rack industry. And eventually, when I got out of the rack industry, signed on with InstaCote, kind of developed some new markets. And I guess here we are today then.
Yeah. So we're going to jump right into our presentation. Here we go. So this is all about polyurea and automotive packaging. We're going to go a little bit over its current application, what makes it a really good component of racks and other packaging, and then roll through a couple of show and tell, you might say. It's a little bit like a case study, but we're really going to show how it's being applied today, followed by, kind of a look forward as to things that are just getting out of development and getting into use cases. So without further ado, get my presentation notes up. Here we go. So why do we use polyurea in automotive packaging? The first really is parts protection. It's making sure that parts that are going through, on a rack, in a bulk bin, in any other sort of container, don't get damaged, right?
Correct.
Yeah. Then the second really big one is making sure that the equipment that you've bought, so any racks or containers, again, stand the test of time. They don't get corroded. They don't get marred and damaged. They, can be on your shop floor for a very, very long time. Next is worker safety. Everything from, wrapping or spraying down a wood piece of dunnage so that you don't get splinters, to, protecting hearing for someone, can be done through different applications of this. And on that same note of hearing, noise reduction. So not only for, protecting people's ears, but being able to maintain communication in a shop. You put a padded foam piece of polyurea on a rack or on like a vibrating hopper, which you'll see a little bit later. you can have a conversation around it. Next, we're going to talk a little bit about what sets it apart from other materials. And for example, like the biggest material kind of we were talking about before this is plastisol dips. Polyurea itself is a 2-part spray-on top coat. And that's about as far as I'm going to get into the actual material science of it, other than maybe some of the materials that it's made with. But the first thing really is its hardness and elasticity, and this is all variable. So the harder it is, the less elastic it is. Softer it is, the more elastic it is. So for example, kind of see here in this camera, or on the camera, this is the wrap coat material, just a foam backed piece of polyurea that is wrapped around this. So you can see that it can get applied and moved around the whole steel bar. But then you could also spray it on to a steel container and have it,
something like that.
Yeah, something like this, and have a really high hardness so that it can, not take impacts and abrasions so badly.
I was going to say the important thing too throughout the whole process is the coating has to be non-marring for Class A surfaces, and that's critically important in the automotive.
Yeah. Next is any environmental concerns, and this is again in more in the realm of plastisol dips. Rick, you can talk a little bit more about that, because I know I've heard a little bit about the environmental concerns of like using a plastisol, but I kind of wanted to get your perspective on that.
Well, plastisol dips have been around forever, and that's pretty much what was standard in the rack industry when I was in the rack industry 30 years ago. The problem with the plastisol dips was, of course, the longer they are on, they're more prone to cracking. And environmentally, when we were working with the playground industry, that issue came up where the EPA was eventually going to be possibly banning the plastisol dips because of different environmental concerns, where that is not a concern with the polyureas. And from the cracking standpoint, which is typically what you saw on shipping racks, the polyureas itself, the properties, physical properties, do not tend to cracking. Probably the worst thing that happens with polyureas, they may fade after a while or change colors, but physical properties on elasticity or that is not an issue, which is a good thing.
Yeah. Next is all about permeability. So this is just the ability of water to get underneath the application so that you don't get rust. In damage resistance, we touched a little bit about anti-abrasion, but this kind of goes both ways. It's that part damage reduction and also the damage reduction in abrasions. And finally, one of the really cool things that Rick's turned me on to recently is the idea of variable grip in application, because this is a spray. You can apply it in different ways where, a dip, you're just dipping it in, getting a coating, that's it. This, you can do things like, we have some examples here, stipple coat versus a smooth coat. So I don't know if you can see that, but yeah, there you go. The reflections in that kind of give you an idea of there's a stippling on there. And then an example of a smooth coat where there isn't. And that's all about grip, because when you put a stipple coat on, you're creating
I was going to say the advantage is, and both the smooth and the stipple coat are broadly used. If say you're wanting parts to slide more freely, you do a stipple coat. You have less surface friction. If you want it to grip a little more, the smooth coating. Most people, when they see a stipple coat, they are concerned that it could scratch a part. it will not scratch apart. It just has less surface friction. But we've used both, and like I said, certain customers like it smooth, other ones do the stipple. They're both widely used.
Yeah. So those are sort of the material properties that sets it apart. And next I wanted to touch on, Rick talked a little bit about himself, but I kind of wanted to have him tell a story about how one of the ways that InstaCote got into automotive particularly. I'll have you take that away.
Yeah. What we were talking about is when I had my rack company, I would go to a lot of the rack review meetings, and Tom Nachman, who owns the InstaCote company, was a friend and neighbor of mine, and I always was fascinated with the polyureas and its application in the rack industry. And I was down at a meeting at Honda in Marysville, reviewing different programs with a lot of the packaging engineers. And I had asked Tom to maybe give me some samples so I could share that with the people and kind of turn them on to maybe new technologies they might be interested in. So we had just some cheap styrofoam logs coated. And when I was at the meeting, I passed out a few of the logs to the different engineers, and they were sitting around the table, touchy feeling, just getting it in. And for the most part, we were getting a good reaction. But there was one packaging engineer in particular that was being a little difficult, and he was not so much sold on the polyureas as a coating, and he was criticizing the durability and the non-marring that I had said would come with the polyureas. So at the conclusion of my presentation, I passed it out. I was collecting the parts, and he was doing everything in his power to persuade the rest of the engineers it's a waste of time looking at it. So he was leaning on his chair, and he just kind of talking to all the other engineers. And as I went by his chair, I'm not sure what came over me, but I just got the coated log, whacked it on the back of his seat. And I think, I'm not sure if he wet his pants or not, but I know I scared the hell out of him. And he jumped up, and I put the log down on the table. And I said, "What do you think of it now?" And he said, "Well, the styrofoam cracked." And I said, "Well, yeah, it cracked, but the polyurea did not. It held together." And it just demonstrating the durability of the coating itself. After that, we started selling coatings to Honda and other customers. But it was just a new technology, and it was not widely accepted, and plastisol was. But over the years, polyurea has become widely used in the rack industry.
Yeah, and on that note, we're going to look into a little bit of how it's used today as kind of a show and tell. So first and foremost is padding and protecting steel, and this is starts with what we kind of showed earlier with this material here. As you can see on this presentation, there is a little bit of a highlight on this CAD drawing of where that would be applied. Go ahead.
I was going to say, what you're seeing there, a lot of these, we get the assemblies. We don't get the full racks. Sometimes we've got them, but our shop is not that big. But we get assemblies, and we coat the assemblies and then ship them back to the fabricator, and then they assemble it on the completed rack. This is pretty much how we do it with metal assemblies, foam dunnage, anything that would go into the rack itself.
Yeah, and then protecting the steel itself is more of a spray-on application. And for example, that little black part, which unfortunately I left downstairs, has a coating on the top of it, but not on the underside of it, so that it can actually slide onto another like mating metal piece.
Correct.
Yeah.
You wouldn't be able to do that with a plastisol dip because it's totally immersed. But with the spray coatings, you can kind of direct the coatings where you want it.
Yeah.
And we can mask off if there's certain areas that you don't want. We put tape masking or make some kind of a jig to hold the part, and we can specifically put in certain areas and avoid certain areas.
Yeah, and Rick was telling me a little bit earlier today about the image on the left, which is actually a dumpster. He was saying that the company that they were working with was having a hard time keeping dumpsters alive, basically. Like they were kind of rusting out, giving out after a year. And putting a spray coat on the inside of it. How long do you think those would last now?
The ones without coating were rusting out in less than a year. It was cementous type material, so the corrosiveness of the cement was eating into it. With the coatings, I think they were saying that they would last 2, 3, 4, 5 years. It would extend the life. Again, it depends on how thick you put the coating on the inside.
And I actually think I just saw a comment from somebody about whether it's going over foam or not. And actually, our next application that we're going to be talking about is going over dunnage. So this is an example of polyurea spray coating over foam. And what would you say the reason is that you would spray foam?
Well, for durability is really one of the bigger areas to extend the life of the dunnage so it doesn't break down, but also the non-marring. Different foams or dunnages could scratch a Class A surface, and there's no solids in the polyurea coating itself, so you would have no damage to a Class A part. But durability is a real big reason for the dunnage.
Yeah, and next we were talking a little bit about wood earlier today, and you were telling me that there are a couple applications that you were looking at in regards to wood, partially for worker safety, but also for parts marring and not getting wood chips into production.
Contamination. The gray wood that you see there was actually with a project in the rubber industry. And when they were rolling the rubber, when it wasn't coated, they would get wood chips in the rubber product itself, which would cause contamination. And so what we did is we put a coating on the wood platforms, so when they would roll the rubber, it would eliminate any contamination of the parts.
Yeah, and then the one on the left you can see is sort of a dunnage suspended in a steel frame. And on the right, that's OSB that's been coated with polyurea. And then finally, the last thing I wanted to touch on in this slide was, this one is steel, but you were telling me a little bit earlier, like aluminum and plastic and steel also is seeing a lot of treatments lately, right?
You're talking about the tooling, holding?
Oh, maybe that's what it is.
Yeah.
But yeah, for dunnage in itself, it can also go over things like, tubing and
Oh yeah.
Yeah.
I was going to say we've seen different plastics, wood, metal, and a lot of times adhesion is an issue with different materials. So over the years we've either developed or tested out different primers to improve the adhesion on hard to coat, like HDPE would be. Very hard to coat to, but we've got primers to adhere to that with our coating.
Cool. And so the next one I'm going to go through a little bit more quickly because I think we're going a little over time. But the applications on container interiors and totes, and particularly starting with totes. What do you see this get applied? Like, what application do you see this serve?
Well, again, with part damage, they need some kind of cushioning on the inside, but we've also seen of late where they have old totes, and we've rehabbed the totes. We get them there, we strip off the loose polyurea coatings or whatever the coating is, and recondition and recoat existing coats so you can extend the life. Instead of building a new tote, you can rehab existing totes, which is saving money.
Yeah, and I'd say that's a fairly similar use case for doing something like a steel corrugated container, right?
Sound deadening and part protection, correct?
Yeah. And then finally, what I think is really cool is, and you said you had some thoughts recently about this, is things like vibrational hoppers and just like parts hoppers generally.
Yeah.
Something that you've applied to. And
Yeah, we've in the past we've done gravity feed hoppers and different types of metal containers. Back then, when we were doing a lot of these, we didn't have the wrap coat developed. I think looking at it now, if we got any of these in here, I would probably put the wrap coat material down too to give a little extra padding, and then totally encapsulate that on the interior, gives additional sound deadening.
great. And so the last slide that I'm going to bring up is actually like a really cool case study. It's not exactly packaging, but it is related to assembly and production. And I think it's just like such a powerful thing because it's saved more than $6.5 million in a year for a company. And that's actually for paint masking. And if you want to kind of do the brief story on that.
Yeah, this is a project that we did for Honda Marysville and actually East Liberty. We did for both plants years ago. And they came to us with a problem that they were having with, this is an instrumentation panel, and it's a two-tone paint that they wanted. And so they would mask off certain areas. And the masking that they were using is a rigid plastic snapped together. I think it was 6, maybe 8 pieces that would snap together to cover the areas that you're seeing in green there. The cover that they were using, they were having that shipped in from Japan. I think if memory serves me, it would cost $110 for the plastic mask. They could only use it one day because when they painted and then put it through the post-cure ovens, the oven temperatures would cause the mask to warp, so they'd have to throw it away. So they asked us if we could come up with something that would last a little longer. So they brought in a Dixie cup and they had us spray it to see if our coating would hold the shape of the cup. So we put a release agent on the Dixie cup, sprayed it, let it cure up, which is just minutes, and then pop it off and it held the shape of the Dixie cup. So the next step was to get an instrumentation panel, tape off certain areas to kind of get the shape, and spray it with release agent, then coat it, and it seemed to hold. So eventually what Honda did in this case is they made some aluminum molds that were the shape of what they wanted coating, which is, if you look at the area, the green in the center, and then at the end were the areas that they wanted to mask off. So we would spray the molds that they gave us, pop off the mask, and then they'd use it as their mask. We didn't know the durability of it and found out later our masking lasted 6 months versus 1 day. Back then, I think I was charging like $25 for a mask, and they were charging $110. And based on the volumes they were running, they calculated savings of approximately $6.5 million per year. We did that program for 3-4 years, I believe. And then I'm not sure what happened, but like many things, they go a different direction.
Yeah. Very, very powerful story. And the final things that I wanted to touch on were what's next. So these are really the things that are fresh off production as far as like R&D and are looking for application. So first things first, ESD coatings, and you tell a little bit about that.
Oh, sure. All of these that you're seeing on the screen there are developed because of requests from customers of issues that they've had. And Tom, who owns the company, very, very bright individual. He's got 12 patents and he's co-authored another one. So for him, developing coatings in that is second nature. So the need came up for anti-static with, I believe it was a military application originally. And we had no idea how to test anti-static. So with our military contact, we were told, here's what you do, Rick. You get an ashtray, you put in cigar ashes, and then you take your coating, rub it on the carpet, and run it over the ashtray, and if it explodes, you got static charge. So Tom and I went over to a local store called the Butt Hut, and we went in and asked if we could have some cigar ashes, and the guy looked at us like we were crazy. And then we explained what we were doing, the military application, and fortunately he was a military person, and we got the ashes. The testing on that is a little more detailed now than in the beginning, but that's how our humble beginning on anti-static. And it's a long-term anti-static. It's not one that dissipates shortly after it's applied. It's long-term anti-static.
And sort of in the interest of time, so that we have a little bit more time to do Q&A, I'll run through the rest of these. Greener materials, for example, we actually have a castor oil sample here, trying to get away from petrochemicals. I think you said something about soy too, right?
Well, actually, it's castor. We tried.
Oh, okay.
Yeah.
So it is castor oil. Luminescence, that started with an application in outdoor play furniture, if I remember you saying that right.
Yes, furniture.
Yeah.
Children's furniture.
And it's kind of been, we were discussing sort of applications in emergency situations in plants, particularly if there's no light, the things can glow for like 14 hours. And then finally, one that I'll give a little bit more time to is patch repair kits. And that is being able to send out a spray-on application to on-site and, have somebody not have to ship.
Well, if there's damage to it on site, rather than pulling the rack out of operation, we send you, it's a hand mix repair kit, and you can fix it with your own people right on site. And so you don't have to take it offline.
Yeah. So that's what we got today for a presentation. I appreciate you all. That's my contact information if you want to get a hold of me, but I'm going to get Sreyas back into the call and take a look at the questions you guys have put up. If you have any additional questions, please put it in the comments of the live stream and we will address it. Thank you. Oh, and just in case you didn't see that, this is the slide for my information. And Sreyas, welcome back. You're muted.
Yes, I am. Hey, unmuted now. Thanks, Greg. That was an awesome presentation, and thank you for. I didn't realize that there are so many applications of polyurea that are almost like not packaging related, but ancillary, like industrial production or some form of enablement. It's pretty mind blowing.
Yeah.
I did see on the LinkedIn chat we did have a couple of questions come up. And I think they're mostly related to hardness in epoxy, maybe we can review those together. I can read them out and you can answer if that sounds good.
Yeah.
Okay. I see first question coming out from Jigar saying, what about the comparison with epoxy as per the cost and life efficiency?
With epoxies, epoxies, the only coatings that we would have that would compete with that would be our polyaspartics, which is a floor coating. And the polyaspartics would be similar in hardness to the epoxies. The difference is epoxies are very brittle, where the polyaspartics have like 15% elongation, so they're somewhat flexible. There's no really comparison to the polyureas. Polyureas range from anywhere from 30, 35 durometers shore A to over 100. Epoxies, I think, would probably be plus 100. Very, very rigid, very hard.
And Rick, I have a question then. From a cost perspective, is it more, there's like a longer term perspective, but from an immediate, like a setup perspective, what's the more efficient option?
Say that again now?
How difficult is it to set up polyurea versus epoxy in your production methods and the actual startup of it?
Well, the polyureas, they're a spray application where the epoxies would be more than likely, they could be spray, but it's different equipment. The polyureas are what they call a plural component equipment. It's heated at about 160 degrees. I don't think you have any temperature heating with the epoxies. Equipment for polyureas are rather pricey. You're looking at, with the new pricing, you might be in the $40, $50, $60,000 for equipment. Guns are, like everything else going up, might be $5,000, $6,000 for a gun. It's a little more expensive to get in it, but you're talking apples and oranges on the coatings.
Gotcha. Jigger, does that answer your question? If you have any follow-up questions, please feel free to post them in the chat. I'm going to move along questions now. I see a question from James Young saying, do you have any recommendations on how to specify the polyurea coating on engineered drawings for more consistent results?
Well, on drawings there, what I usually, when I'm talking to a customer, I need to know what we're talking about, what we're shipping. I could either recommend a softer coating. Maybe you don't want a part to slide. I'd go with an M12 or an 800, which is a softer coating. You're talking about stampings, I'd probably go with the harder coating that would hold up maybe to the metal cutting into it. It really depends what the product is you're shipping and what you're trying to accomplish.
And Rick, I guess a follow-up question, kind of in the spirit of James' question, you must have seen a lot of drawings come about, and are there any things that you've seen in the drawings that made it more clear for you to understand as the person providing it, like some best practice that someone could do in their designs that would make it better for the overall deployment?
Well, usually when I go to the drawings, what I'd prefer to see when I get an entire rack, maybe 15, 20 pages, I'd like to see just the drawing of what you want me to coat rather than going through the entire drawing. And a lot of times in the drawing, it doesn't tell me how you want it coated. If it's totally encapsulated in certain areas that you don't need coating or the mask off, or let's say you need a heavier coating on one side and you can go a lighter coating on the other sides. That's all stuff that when I get a drawing, I usually pick up the phone and call and try to pick their brains a little bit and saying, okay, what are we trying to do?
Gotcha. So, I mean, I'm hearing that usually there's some kind of supplementary instruction that follows the drawing as well, and there's something to it that maybe can't fully be captured in a drawing, has to be specified either in conversation or process document or something of the like.
Exactly. A lot of times with the dunnage, the foam dunnage, when I get quotes in there, people are quoting maybe 6-8 pound crosslink, and I'm thinking, well, why don't you go with a 2 pound? You're putting the coating on it, and 2 pound is a lot less expensive than a 6 or 8 pound. So why get heavy coating or foam if you're going to put a coating on it?
Makes perfect sense, and I guess it's really unique to each situation. Each application has some form of the expertise that can be leveraged to it.
Yes, yes.
That's awesome. James, if you have any follow-up question on that, feel free to post in the chat, and we can get it answered as well. I see another question coming from Camille. I'm going to read this one out loud. It says, this is a lab question. What ISTA test protocol do you generally recommend in general for electronic components made for automotive shipped across a border? Truck, air, potentially boat, barge, fragility data not available and is pushing back to require ISTA testing before large-scale production. Thank you. Or it says, I would love to hear your feedback, and thank you. So that is a great question. You know, it's almost like in my head when I think about it, it's like a Plinko board and it's like a decision tree. So the first stage decision is what's actually being shipped. You know, is it small components that go in a box and one box gets shipped at a time? If it's unitized at a skid level, then, you know, generally you'd pursue a skid level test. And what I'd say for that is 3E, 3B are good skid tests. For a smaller box, there's another test called 3A that's more reflective of how a FedEx carrier might manually handle a box versus mechanically handle a skid or a rack. And that's the real delineation between the test methods. With respect to fragility, I mean, the way that can become super relevant, one of two ways. The first is that if you're seeing field failures, but then you're not seeing test failures, you might consider utilizing fragility data or failure data to further increase the severities, to induce failures to a point that you'd like to see it or to prove something. But outside of that, I think the first good stage starting line, especially in a large, many of the manufacturers of PCBs and contract manufacturers we work with, they consider ISTA 3A for a box, ISTA 3E for a unitized load, like all the same, and 3B if the customer has irregular shipments of boxes that are put on a skid and just thrown in a truck. So a couple of different avenues there. And what I'll do is after this presentation as well, we'll share copies of our slides and our contact info. So there's a more detailed response required. You can feel free to send me any particulars of the situation, and I can get a stronger answer for you.
Yeah.
And Greg, with that being said, it looks like we are fresh out of questions. I mean, if, oh, there we go. Do we recommend tests prior to production? Of course. And the thing I would say is the production in two regards. One is that production with respect to the packaging production. Highly recommend doing investigatory tests at least of, you can do a bunch of these yourself. I mean, to be honest, just drop it a bunch of times and look up the test spec and stuff like that, right? And that's a really good first stage test. If you can't pass that at your house, then I mean, why send it to a lab, right? Save yourself the headache, right? But with all that being said, after all that is done, then main recommendation before you lock in your package design and before you formalize it, get all your lines running, do a test on it. And then the other thing is if there's any meaningful changes to your actual product, because when you think about packaging, the whole dynamic system of it is there's essentially an outer wall shield, there's the inner part, and then how compression works. The configuration of the unit inside individual shell, along with the void fills and the different spaces represented, are all part of a mechanical load bearing system. So if there's meaningful design changes in the orientation it's placed in, how many are stacked high, what the enclosure looks like, I highly recommend retesting for different dynamics if that's the case, especially density changes can be very meaningfully different. Sorry, Camille, I lost my tab. I'm just pulling it up again. I saw your question and then
I think there's also somewhat of a delay too, so another question might come in a moment after it all catches up.
Okay, I see more follow-up questions, and Craig, Rick, I think some of these are for you. Jigger asks, what about the comparison with epoxy as per the cost and life efficiency for polyurea?
We answered that a little bit earlier, I believe.
I think that this one is oh yes, we did. We did answer that one. I'm not seeing Camille's most recent two questions then.
Yeah, her most recent question was, do you recommend tests prior to production? So I think we're all caught up.
Oh, awesome. Okay.
Well, yeah. So we are planning on doing more of these shows, more testing related things towards packaging broadly. I think the next show that we were considering doing is about e-commerce. Would that be right, Sreyas?
That's correct. And yeah, wealth of topics in that regard as well.
Yeah, we were, on our end, at least, we were thinking about working with Geoline, our lean manufacturing sponsor or partner, who works a lot with tube and joint manufacturing systems. So
I think that would be the perfect focus. From our side, we were considering talking a little bit about warehousing protocols of Amazon, different e-commerce suppliers, industry-leading best practices, as well as how to avoid chargebacks in those kinds of environments for shopping, shipping, and anything in between.
Yeah. On our end, I think it would be partially sort of the facilitating equipment that you would use in fulfillment. So.
Good deal.
Yeah.
Hey, Greg, what do you think? That's probably about 4 weeks up, right?
Yeah, I believe so.
Yeah. Please stay tuned, and we will definitely share more information on the next session of Built for Motion.
Yeah, absolutely. We have the way we have this all signed up on LinkedIn. We will reach out to you via your contact details and make sure you have everything moving forward.
Awesome. Well, I don't really see any more questions coming out. I think maybe we'll just leave it open for another minute. And if there's nothing else, then thank you everyone for joining us today. It's been a real pleasure to go through this first session of Built for Motion with you. Yeah, Greg, Rick, and the team, everyone at InstaCote, TWMSR, the whole team of Megalab supporting. We are here to support you. If you have any questions after the fact, feel free to shoot us a message as well, because I think the best questions are always generated in the moments after, right?
Yeah, absolutely. As soon as the pressure's off. And I wanted to throw a shout out to Sreyas too. We actually met as strangers at Autotech earlier this year in Detroit, or just outside of Detroit, and it's just been like really great to build a friendship and professional relationship with him since then. In Michigan, in Canada, and just over Zoom and Google Meets and whatnot. So thought I'd throw that out there.
Likewise, I'm really excited for what we're going to do with the series and taking on the world of packaging and presenting more and more interesting topics with you, man.
Yeah, absolutely.
Well, maybe, Greg, you want to end it then? I think this is a great session.
Yeah, I'll do a sign off. Thank you everybody for coming out, spending time with us today. It's been really great getting your questions, being able to share, this ever expanding world of packaging that we all work in. Have a great day, and I hope to see you all soon.
Bye, everyone. Thanks for joining.
Bye.